Hello to everyone and welcome back to KET Academy. In today's video we are going to be answering MEng 2019, and for those who do not know, MEng simply means Master of Engineering and MARCH simply means Master of Architecture. So we are going to be looking at the first 10 questions for 2019, and for those interested in getting the part 2 of the video, because the part 1 will simply be the first 10 questions, so the part 2 will be the next 10 questions in the set. So for those interested in the video, they simply please you can put that in the comment section. So before we get into solving the questions, I'm going to give a basic statistics and a general advice to all those writing this particular examination. So I'm talking from experience, and believe me that what I say, if you apply it, you are not going to face problems. So we know that for this engineering ENSTP, the public works concours, there are 100 questions, in which there are 40 mathematics questions, there are 30 physics questions, there are 15 chemistry questions, and there are 5 English, 5 French, and 5 general knowledge. For you to focus all your attention on mathematics, physics, chemistry, and English, and try to forget about French and general knowledge, because with a time limit you cannot use that time to get or to know French or to know all the answers in general knowledge. So I'm not trying to say that don't focus on that aspect, but it will be strategic for you to focus your attention in the high scoring part of it. So see that maths alone accounts for 40% of the examination, while physics accounts for 30%. So somebody that focuses their attention on this part, you'll be able to have a higher chance of succeeding than somebody focusing their attention on general knowledge. So that's something that is very common to see. So for the general knowledge, you never know what comes in the general knowledge, so it's always better to be updated about what is happening around you. There's no need paying your attention, especially during this critical moment, reading general knowledge textbook, because it will not help you. The highest thing you can do now is answering past public works questions, because most of the times those questions will repeat. So I think without much waste of time, we're going to get into the video. Question 1 says that let T be a right angle triangle whose hypotenuse is 5 centimeters long and whose edges have integer length. The area of T is... Okay, now the question says that T is a right angle triangle and whose hypotenuse is 5. So I've been given the hypotenuse is 5 here. The hypotenuse is 5. So there are two conditions here. When they say a triangle is a right angle triangle, first, the angle, it must contain an angle of 90, and second, it must obey the Pythagoras theorem. So according to the Pythagoras triplets, there are some angles, or we call them the Pythagoras triplets, that obey the Pythagoras theorem. So some of those angles include we have some of those triplets include, we have 3, 4, 5. This is the first triplet. The next one we can have 5, 5, 12, and 13. The next one we can have 8, 15, and 17. So for each of these triplets, if you take the highest number, you square it, it will be equal to the sum of the squares of the other two. For example, let's take the simplest one. In this case, we have 5 squared. 5 squared should be equal to 4 squared plus 3 squared plus 3 squared. So clearly we see here that 25 is the same as 16 plus 9, which is very true. So in this case, since the hypotenuse is 5, therefore our Pythagoras triplet will simply be this. Our Pythagoras triplet will simply be this angle here. Therefore, to simplify it, if we draw that, we are going to have our angle 90 here, we are going to have 5 here, and we are going to have 3 and 4 here, or even 4 and 3 there. It doesn't matter. Now looking for the area of this triangle, we know from the formula area is a half the base times the height. So since we see that there is multiplication, we can either have the height times the base or base times height. So it will simply be a half times 4 times 3 times 3, which will give us 6 centimeters squared. So looking at that, our answer is B. That's the answer for option A. Now question 2 says that let S be a segment of length A and consider all right angle triangles having hypotenuse equals to S. The locus consisting of the vertex opposite the vertices opposite to the hypotenuse of all such triangles is. So here let's try to represent our diagram. We have been given a line segment S of length A, and we have been asked to draw the locus consisting of the vertices opposite to the hypotenuse of all such triangles opposite to the hypotenuse. Now, and consider all right angle triangles having hypotenuse equal to S. So we want to draw all our right angle triangles having hypotenuse equal to S of length A. So in this case, what do we know? We can draw the best the easiest right angle triangles we can draw. The first is this. The angle there is 90, and the second is this. The angle there is 90. So we see that if we want to link our locus of the point opposite to the hypotenuse, we are going, if we link these 2 points, we clearly see that it gives us a circle of diameter A and of radius A on 2. But now, according to Thales theorem, if we have a circle, let's say we have our circle now with the center and the diameter this. Now this angle at the surface, if we have this our point A, point B, and this is the circumference, our point, the angle subtended at the surface is always 90 from the, no matter how you do it. So no matter how you take it, the angle will always be 90 at the surface. So doing that, it clearly confirms the assumption made with the 2 triangles. Therefore, according to the Thales theorem, the locus will simply be a circle of diameter A and of radius A on 2. But looking at our answers, we see that no option there says that it's a circle of radius A, of diameter A. So we are going to take the closest answer, which is a circle of radius A. But I will highly appreciate if anyone brings up a better way in which we can represent this question. So our answer here will simply be C. So the next question says that which of the following line is perpendicular to the line this? Now, when 2 lines are perpendicular, this is what they mean actually. It means that they meet at an angle of 90. Now, when we talk of a line being perpendicular, the properties of the line, we are going to describe the properties using the gradient of that line. So if we have a line with a gradient m1 and another line with gradient m2, then if they are perpendicular, then the product of their gradient must be equal to -1, right? So this is the first condition that we are looking for. Now, in order to get the clear idea or the value of m1 directly, we have to express our equation in the form y equal to mx plus c, where m here is the gradient, c is the y-intercept, and y is just the y coordinate. So trying to apply that from our equation, if we send y to the right hand side, we are going to have y to be equal to 2x plus 1. So from here, what we can do, there are 2 ways in which we can go about it. The first way is either we start from the options, means a, b, c, d. We take each equation, we express in the form y equals to mx plus c, and try to see if we can take the gradient and multiply it with that of our original equation, which is y equals to 2x plus y, or we either used our formula. In this case, we consider our m1 to be 2 and we don't know m2, so we look for m2. So m2 will simply be equal to minus 1 all over m1, so which will be minus 1 all over m1 is 2, so minus a half. So simply we are looking for an equation whose gradient is minus a half. Once we see an equation whose gradient is minus a half, therefore that will be the line which is perpendicular to our original line here. Now looking at this equation, let's go to b. Let's try to make y subject here. So if we make y subject from here, our b says that if we have 2y to be equal to, if I send x the other way, I'm going to have minus x, and if I send 3 this way, I'm going to have plus 3. So if I divide all through by 2, I'm going to have minus a half x plus 3 on 2. So here clearly you see that our gradient here is minus a half, which is what we're looking for over here. Therefore the solution, an equation which is perpendicular to this one, is b. So our answer here is b. Now moving forward, question 4 says that let x be a real number, then sine of x plus 12 pi plus cos of x plus 12 plus pi on 2 simplifies to. So in this case we are going to simplify our result. Now to simplify sine of x plus 12 pi, we are going to use the idea of periodic function. We know from the formula which says that x plus nt, this will simply be equal to f of x. In this case we are talking of the sine and the cos function, and we know that these functions are periodic with period 2 pi. So if we can express 12 pi as n times 2 pi, therefore this function simply simplify to a sine x. So what I'm saying is sine of x plus 12 pi can be written as is equivalent to sine of x plus 6 times 2 pi, which is the same as sine x, So this is the answer for the first option. Now the second function, which is cos of x plus pi on 2, here we are going to use our compound angle identity, and we know from the compound angle identity which states that cos a plus b is the same as cos a cos b minus sine a sine b. So we are simply going to go directly and apply the formula. In this case we are going to have cos x cos pi on 2, which is 90, minus sine x sine 90. So here we need to take note to simplify cos 90 in this case. Cos 90, let me just erase this. Cos 90, from the cos graph we have, this is our cos graph. The cos graph starts here. Now this is 90, this is 90 here, and the value when theta is 90, cos theta will be 0. So 0 times cos x will simply be 0. So now minus sine 90 for the sine graph. We know that the sine graph starts from the origin, something like this and like that. But we see that sine 90, this is 90 here, this 90, and the maximum value for cos and the sine graph is 1. Therefore at the maximum or at the peak, sine 90 is 1. So 1 times sine x will give us sine x. But now we saw that before we had sine x, so which will be sine x plus minus sine x will simply give us sine x minus sine x, which will be 0, which will give us 0. So our answer there is B. Question 6 says that the second digit from the right of the number this is. So since we have been asked to look for the second digit from the right, then there's no need doing the entire multiplication. So the trick here is just for you to focus your attention on the last 2-digit number, since we are dealing with values from the right. So here we are going to do this, the multiplication of 96 and 69. But you have to take note that in public works there are no calculators, so you do the multiplication manually as it was done in primary school. So we know 9 times 6 is 54. So we have 54. We simply write our 4 and carry 5 and carry 5. Now 9 times 9 is 81 plus 5 will give us 86. So we're simply going to write our 86. So we're finished with 9. We'll go now to 6. 6 times 6 is 36. So we are going to write 6 and carry 3. And 6 times 9 will give us 54. 54 plus 3 will give us 57. Now we're going to add these numbers manually. So see, 4 plus 0 will give us 4. 6 plus 6 will give us 12. Write 2 and carry 1. 8 plus 7 plus 1 will give us 15. Write 5 and carry 1. And 6, which is 6,524. But since we're asked to look for the second digit from the right, therefore the answer will simply be 2. Okay. Now question 7 says that the exact order among the numbers is. So here we're going to consider 2 examples first of all. So if you have a number, let's say 2 and 3, it is clear that 3 is greater than 2. Now if we square these numbers, we're going to have 3 squared greater than 2 squared greater than 2 squared. Now 3 squared is 9, greater than 2 squared is 4. This holds, right? So if we have a number and it's positive and we square the number, is the inequality is still going to hold, but it will not hold when the numbers are negative. Take note, we are dealing with positive numbers here. The square root of a number is always positive. So in this case, if we consider 4, so we see that 4 squared will simply be 16. So we're going to keep that aside. 16, we'll keep that aside. Okay, if we take root 19 and we square it, and we square root 19, we are going to have 19. And if we go on, now there's a little trick here you need to do to simplify. Now squaring this is going to give us another complex form of it, but we know that 8 can be written as 4 times 2. 4 times 2. So squaring it, we are going to have 2 root 2. But we know that we have root 2 here. Root 2 plus 2 here will simply give us 3 root 2. Now squaring now that 3 root 2 will give us 18. So the square of 3 root 2, all that squared, will simply be 18. So looking at this, we realize that root 19 is greater than root 2 plus root 18 plus root 8, and it's greater than 4. So clearly our answer is A. Now question 8, I'll be giving. Okay, question 8 says that let T be a triangle having area A. Let T be transformed to another triangle T prime according to the following rules. One of the edges is a half of the corresponding edge of T, and all angles remain equal. The area of T prime is that. So in this case, we have been given two triangles. We have been given two triangles, T and another triangle T prime. And here, before we continue solving, I would just like to mention the fact that there are some two concepts you have to take note of. We talk of a congruent and similar figures. When we say a figure is congruent to another figure, let's say triangle T is congruent to triangle T prime, therefore the sides are equal and the angles also are equal. But now when we talk of only similar figures, it means that here we're dealing with the angles are equal. In this our case, they say that all angles remain equal, therefore they are similar figures. Now there are two ways in which we can find the area of the transformed figure. We can either use the ratios, because we know that area of the of the normal triangle divided by area of the transformed triangle must be equal to, now the side of the, we can say the length of the normal triangle divided by the length of the transformed triangle. So we know that if we let our length here of the normal triangle to be x, so the length of the transformed triangle will be x on 2. So putting in our values, we are going to have the area of the transformed triangle here was a, it was stated in the equation. So we have a divided by area of the transformed triangle, which we are looking for. It should be equal to the length of the transformed triangle of the original triangle is x. Now the length of the transformed triangle is x all over 2. So we see that our x is simply going to cancel. The 1 divided by a half will be 2. Therefore here we are going to have a divided by area of the transformed triangle will give us 2. Therefore we are looking for area of the transformed triangle, which will give us a on 2. Therefore our answer here is B. Our answer is B. Now question 9. Which one of the following line is a tangent to the ellipse 4x squared plus 9y squared equal to 72? Now here, when they say a line is tangent to another, let me illustrate it. If we have our circle here and we have another line that passes here, now this is our tangent, this is our circle. Now this point where it touches, there's just one point at which it touches the circle. This is the point which where we can say that is a point of intersection. That is a point of intersection, and there only exists one point of intersection when it comes to a tangent intersecting with another figure. Now here we are going to apply the idea, because the question says that which of the following line is a tangent to the ellipse this. Here we are going to use the answers to solve the questions. So we are going to test if this line, the options A, B, C, if any of these options is really a tangent to this ellipse, it means when we substitute the value of this our line, we are going to have just one solution for the one corresponding solution for y. So let's take for the first case x equals to root 19. If we put it in our equation here, we are going to have 4 times root 18 squared is 18 plus 9y squared equal to 74. So we are going to simplify. 18 times 4 will simply be 72. So will give us 72 plus 9y squared equal to 72. So in this case we have 9y squared to be equal to 0. So we have y to be equal to 0. So we see that there is just one value of y for when x is equal to 18. So we have our point of intersection actually to be root 18 and 0. Therefore our answer is A. But now I'm going to look for solve the other options. When x is minus 1, let's try to put it here. So if we put 4 minus 1 squared is 1, so 4 times 1 will 4. So 9y squared will simply give 72 minus 4, which will give us 88. So we see that there are two values here. So B is not the answer. So the same thing will occur for y. In fact, y is a straight line. Y can be written as minus x, which is a straight line of negative gradient. So it can never be the answer. D is also a line, so it's a line, so it can never also be the answer, because if in this equation we substitute everywhere we see y, we put minus x, we're still going to come up with two solutions. Now if we put minus x squared will give us x squared, so 9 plus 4 will give us 13 x squared equal to 72, which will give us two solutions therefore clearly telling us that it is not a tangent, because for it to be a tangent there must be one point of intersection. So this is also a trick you can use in an examination, because if you are faced with a question but you don't know how to go about it, you can try to look at the similarities of the answers when when particular answers are very similar and there's one odd answer. Therefore, that answer should actually be the correct answer. Now, question 10. The solution of the inequality x cubed minus x less than or equal to 0. So, inequalities, especially in this concours, are very trickish. So, you have to be very careful when dealing with inequalities. But this is a relatively simple one. So, in this case, we have, if we factor out our x, we are going to have x squared minus 1 less than or equal to 0. Here we look for our critical values. The critical values simply are values gotten when we equate our products to 0 or our factors to 0. So we are going to have 0. We know this is a difference of 2 squares, so we are going to have minus 1. We are going to arrange this on a number line in order of increasing, in order of magnitude, or in order of value. So the smaller value will come first, minus 1, and the next one will be 0, and the next one will be 1. Now we have separated our number line into 1, 2, 3, 4 sections. We are looking for values for which in each of these 4 sections the value should be negative, or our function should be negative. So if we take, let's say, a value, let's say 2, and we put it here, we see that 2 squared will be 4 minus 1, which will give us 4 minus 1 is 3. 3 times 2 is 6, which is a positive value. So normally here will be a negative, here will be positive, here will be negative. So we see clearly that the region of our interest will be this region, and also this region. This will be the region of interest, because we are looking for the values for which in that region it is negative. But do not usually assume like this, because I assume like that because there was no value here that was like squared. In cases where you have things like this, or that square, it will not always work correctly. So it's better for you to solve it normally. What I mean is, you look for a value that is between 0 and 1, let's say a half. We put it here. So if we put a half, we are going to have a half, all that squared, minus 1 times a half. So we're simply going to have 1 on 4. So a half into 4, 1 on 4 minus 1, which will give us minus 3 on 4. So it will be minus 3 all over 4, which will be negative value. So the same thing will go on and on. You can take, let's say, negative 2. You see that the value actually be negative, because here it will be positive, but negative 2 times that number will give us negative. Okay, I think we'll end here for today. For those interested in getting the part 2 of this video series, you can please put in the comment section. If you have any sibling, if you have any brother, sister in Form 3, 4 and 5, upper seat, lower seat, then you might share this video, you might share the YouTube channel with them, because I'll be uploading videos to help students from all over Cameroon and, if possible, Africa, to get the basic knowledge in science, technology, engineering, mathematics and arts. Okay, thanks for watching, and please make sure to subscribe to my channel, and also like the video in order to support me, and see you in the next video.